that you could not attend. So with this, I see already our first speaker is all ready, I think, and set up. So it's Professor Ioannis Athanasiadis.
That was very good, Miki. Thank you very much.
Thank you. So he is professor and chair of artificial intelligence at Wageningen University and Research. So he has, he's in the middle of what you're talking about. So he uses artificial intelligence to address, also in our ICA domain, these global challenges related to food security, agriculture, and ecology. So he develops artificial intelligence systems to help farmers, policymakers, stakeholders, and it is for the benefit to make better decisions, because we have to make decisions all the time. So how can we use it? But also to improve our understanding on these complex system interactions with, of course, all these data-driven technologies. So I look forward to your talk, and thank you for accepting our invitation. The floor is yours.
Thank you very much. It's great to be with you this morning and share some of our experiences in Wageningen on integrating AI knowledge and skills in the curricula to prepare students for the workplace. So my name is Ioannis Athanasiadis. Thank you, Miki, for your kind words. And I will say a few things for me, mostly as a disclaimer about who I am and what is my background. So I was trained as an electrical and computer engineer, but all my career I was working on applications of artificial intelligence in ecology and agriculture to address global challenges. And since a year ago, I'm leading the new AI chair group in Wageningen University. So to start this talk, I don't think I need to convince you that AI is everywhere. We use it for almost everything. This is how I survive in the Netherlands without speaking Dutch. This is how we are buying things. This is how advertisements are coming to us. But also, gradually, science is also changing. Today, AI pushes the scientific boundaries forward by helping scientists to solve several complex problems in across several disciplines. It powers the detection of skin cancer from images. It can predict how proteins fold. It can restore ancient Greek scripts from palimpsests, and it can discover faster algorithms for matrix multiplication. I think we haven't forgotten that last year, 2 Nobel Prizes were associated to AI and data-driven discoveries. So in these environments, there is a huge opportunity because as a Nature Food editorial was mentioning a couple of years ago, we have all things at hand. We do have big data that we have been amassing in the past years. We do have computational power. We are developing experience. So there are immense opportunities opening up for tackling global challenges, problems more accurately, more inclusively, and in new ways. And this is something that we have observed in the green life sciences in the past decades happening. A great example is remote sensing for precision agriculture and livestock farming. A number of scientific studies over the past 25 years, originating back to the work of NASA in the early 2000s, have shown that remote sensing images can indicate where crops are under stress. Today, these tools are already getting in the hands of farmers and are changing the way we give advice, the way we are making decisions in managing crops and addressing complex environmental issues related to water deficit or nutrient management. A similar great success was what happened with machine vision in plant phenotyping. It started with a couple of geeks, a couple of, let's say 20 years ago, who started applying machine vision algorithm for plant phenotyping tasks. Today, this has been scaled up to that extent that we have massive facilities for plant phenotyping that are automated and can measure traits with cameras and sensors at an unprecedented speed, but also with better, with less errors than humans. So AI is able to estimate plant traits in these facilities with lower error rates compared to if humans were doing it. And to start a little bit more advertisement of my own work, I'm really proud of some work we have done where we started coupling machine learning with process-based models for estimating phenology in cherry trees. This is a work we've done with a PhD student of mine that was published earlier this year, where we have shown that by coupling machine learning with process-based models, we can develop a new generation of hybrid models that can be trained with gradient descents and are able to improve predictions when we are building models in new locations, but also for new cultivars, and we extrapolate in space and time. Similarly, we have been working a lot in benchmarking and testing how machine learning methods are working. This is work we are doing together with the ACMIP community and the Machine Learning for Agricultural Modeling group, where we brought together data at the global level for benchmarking how AI is performing and helps us to estimate yield gaps and productivity of crops at the global level. But also it helps us with building curricula in with extension and building and translating knowledge into practice in several applications. Some experience we had together with FAO in Wageningen research, we were looking how we can use large language models to build multilingual, interactive, but also trustworthy chatbots that can, where farmers can ask questions and get answers to that, or even develop training curricula for specific targets. Last but not least, we have been using AI for tracking climate policy adaptation, and this is something that has changed how social science is happening, and now we can really go into massive data-driven methods for parsing through documents, collect evidence, and change the way we're doing social science research. And this is some work we started with some colleagues here in Wageningen a few years ago. And now with the new advances in large language models, we can really bring these tools in very, very mature performance. So in a way, I think I have persuaded you, or I tried to give you some indications that AI is changing the way that we are doing science. That is a work that have been published last year that shows the exponential growth of AI diffusion across different scientific fields. And if I blow up the numbers a little bit, it has been a huge change in environmental sciences, in biology, but really much less in agriculture and food, even less than philosophy or history. So there is also different drivers, and the change that AI brings in different fields is not always the same. One reason for that is that the fact that a key element of the recent AI success was the use of ever-increasing data sets. By using public digital assets like the internet, training data sciences have grown immensely from more than 6 orders of magnitude in the past decade. But if we contrast with agriculture and environmental sciences, the data that we have are typically smaller. If we look into agronomic trials, the most rich of them are in the order of hundreds, maybe thousands. And if we look into breeding trials, we go to the order of 10,000s. And if we go into phenotyping facility, we start having data sets in the order of millions. That somehow suggests that, well, if we use methods that are 20 years old, we're in a good shape. So we're missing all the innovation that comes from what happened in the past 20 years, because we don't have the data. So, and we're never going to have them in the green life sciences. We're never going to be able to, because data are expensive, it requires experiments, it requires facilities. So there is a gap, and this is why we see that AI is penetrating at different speeds between different disciplines. The other key problem that we are all familiar with by now is that the current paradigm for AI is good when it generates stories and text, but then when we want to reproduce facts, it starts hallucinating. And this is a very nice photograph that some students of mine identified, that it shows how even after having AI being trained with millions and billions of images, it still hallucinates about human body anatomy. So that's a little bit challenging. That means that the current methods have limitations, and this is why in several generative AI methods that create images, we see them struggling with details. So, for example, hands or fingers, teeth tend to appear distorted, unnatural, or messed up. And similarly, when generating text, the prose is great, but the details are often not. So these are kind of the landscape where we stand. And I think it's inevitable that AI is changing the way we conduct research. At the same time, our jobs change because we need to have new skills to be able, and our graduates need to have new skills to be able to perform research in this different landscape. At the same time, there is a huge demand for these emerging skills across the industries and a very big gap in the market for AI talent and a huge competition. And this is something that I've been hearing from interacting with companies, that they have struggled to attract the right talent. And when they do, they're not ready for green life sciences jobs. Because most computer scientists trained like me, we know nothing about nature. We understand nothing about biology. All our curricula are designed with examples about banking, entertainment, business. And then when you bring young graduates from computer science background, they really struggle with biological problems. The uncertainty of biological systems. They don't have the way of thinking for being challenged with complex systems and the design of those systems. And this is something that many companies in our domains realize more, that even if you get AI talent from the current AI pool, which is very competitive, it cannot perform. So there is a gap for people who understand the domain very well, but also can perform in such an AI challenged, let's say, landscape. And this is also something that has been confirmed further from the Future of Jobs report at the World Economic Forum that was published earlier this year, that shows in agriculture, forestry, and fishing, for example, the key role for business transformation is AI and machine learning specialists, which is needed at a double rate compared to farm workers or other agricultural workers. So the potential for machine learning and data-driven discoveries in our sectors is really evident to the market. But also, when they look into the key barriers for business transformation, is exactly the skill gap. So next to things related to the amounts of data, technical infrastructure that I presented before, the number one barrier for transformation in our sectors is the skill gap in the labor market, which makes very clear that we need to do something about this. So what do we need to do? I think we need to realize that AI is relevant for all learners in green life sciences, but also that we need to have not only a shallow understanding of AI, it's not a tool that we need to learn how to use. So my view is that we need our students to understand the foundational concepts. They need to understand algorithms, data science, machine learning, AI, and how things work under the hood. Because if they understand how they work under the hood, then they can practice critical thinking. They can be using them for solving the problems they want and be able to do that in a responsible way. So the way forward in terms of the critical AI knowledge is how we teach them to solve problems in AI-infused environments, because this is how their workplaces would look like. AI would be in their workplace. Even if we don't want them to use it at the university, the companies will encourage them to use it. So how do we do that in our classrooms? And I will share some of our experience and my experiences and of my colleagues' experience here at Wageningen University. How do we bring AI in the classroom? The first principle that we are practicing a lot is learning by doing. So what we are doing, we use interactive notebooks, good infrastructure, and practice a lot in low pace, mix theory with practice. So we don't longer have in my courses lectures and practicals that are separated, but we mix them. We do things and we discuss them. And this way, we want to stimulate them not only in doing, but also understanding the principles and the methods, what happens behind what they do, and have several discussion exercises. And we do that most of the time by working in teams of two, where we share notebooks, data, and documents, and we practice pair programming, where one student is the navigator and the other is the driver. So even if they are working in an AI-fused environment and they use code completion tools or AI for different tasks, they are still part of the exercise is to talk and to change roles. One is talking, like when how they do in car races. One is driving and is focused on doing it, and the other is thinking and guiding them. And this is called strong style pairing, where the navigator makes the decision and the driver needs to implement it. But when you have an idea, you ask the other member to do it and you tell it. So in this way, we can have them have a very deep, gradually have a deeper conversation of what they do, to have ideas, discuss them, interact them, and implement them at the same time. But also we practice a lot of activities in the classroom for giving peer feedback. So we are using this concept of conversations where we have students sitting on tables with people not from their teams, and then each one presents their work, asks for feedbacks, gives tops and tips to each other, and this way they're learning from each other and learn also to think and practice critical thinking in their activities. Another thing that we do is that we talk about collaboration, plagiarism, and how this is changing in the AI era. This is something that I had in my syllabus even before AI. So I was talking very openly about with my students already in the first lecture what is allowed and what is not allowed. That we want them to collaborate, but we don't want them to plagiarize. And then now what I do is then we discuss in classroom, what does it mean? So this is what we have been doing 10 years ago. And then we were saying, well, if you create an exercise or a piece of code that somebody else have written, you cannot put your name on it. That's plagiarism. So how does this change with AI? And then we make rules together on how we are using AI in classroom and how we make the help we get from AI in writing code as something that we explicitly disclose. So as in the past, we're saying, okay, finding a program on the internet, change the variables and the comments and put your name on top and turn it in, that's plagiarism. Similarly, doing the same with an AI chatbot is something that is plagiarism. So you need to be very clear of what you have done yourself, what you have thought yourself, and what you got from elsewhere. And I think being open about why we do certain things makes it also very clear with the students. So that's why we have introduced, as an organization, a traffic light for the use of AI, where to make rules more clear. And then we have a red traffic light where students are explicitly forbidden to use AI in their work, or have a limited allowance to use it, maybe for brainstorming or ideation, but not for submitted work. That's something I do in my class when I ask them to develop code and learn algorithms on how AI works. I tell them, look, the solution is in the book. I want you to spend the next hour to think the solution of yourself, because this is how we learn, and be very explicit about that. And in other times, we allow them to do more things. And in certain cases, it could also be that do whatever you want. It's fine. Yeah. But then it's up to us as educators to make clear what are the boundaries and also how these are related to the learning goals of the activities we are doing. But also what we have been doing together with Harm and FAM is to develop e-learning modules for how we use generative AI, in this case for programming in the life sciences. So we created an e-learning model for everyone, and it's available on the e-learning platform of the university, where in an hour and a half, they can learn how Gen AI works, realize what are ethical and privacy concerns related to that when they're writing codes, but also apply strategies for responsible use when we are programming or learning how to program. So we have exercises like this where we ask them to play with generative AI tools and ask them to write functions, but then test them to see if they do what they really want and show them how they can do that. And this is a very important aspect that has been also brought up recently, actually last week, on Nature Computational Science, that there is a new threat to the validity of scientific software by overusing AI code assistance. Because if we have a new generation of scientists who are not trained how to program, but they can produce scientific software that is not tested as thoroughly as commercial software, there is an increased risk of undetected errors, a decline in code understanding, but a huge risk for compromise in reproducibility and scientific integrity. And that may even lead to loss in scientific transparency, because we will need to be sure that the code we produce is doing what we think it does. Yeah. So there are dangers coming with AI, and these are occasionally amplified in research environments. And in that, we need to be aware, but also prepared. So in such a fast-changing environment, what is the way forward? And what is a good strategy for our institutions? I think effective AI integration strategies for learning involve 5 things. One is project-based hands-on learning. Our students need to get experience and be critical about that. It requires also interdisciplinary collaboration. So it's not only, it requires skills both from domain science, but also data science. And it also involves the use of AI-driven tools for practice, for getting feedback, and for solving scientific problems. And part of that is actually practicing responsible AI use. So we need to show them how to do that and think critically about it and discuss ethical, legal, or privacy aspects that are emerging. The other one is that as we move into an AI-infused working environment, we need to develop AI-infused curricula. And that requires aligning with learning goals, but also with job market needs. We cannot ignore what happens in the market and how future working environments are changing. The other one has to do about scaffolding progression. We need to introduce concepts early and deepen later, and infuse AI across different subject areas. Adding a course on foundational concepts of AI for research, I think today is an essential course. Something like AI in science and engineering or AI for research. And that needs to be for all students, not just for future coders or bioinformaticians or geeky side of scientists. All scientists, even the most applied ones, need to be exposed and need to be prepared for this transition. Another thing which is very important is also building capacity and infrastructure, because we need also to have resources and training for our teaching staff. We need ongoing professional development, but also arrange access to infrastructure that many of our universities don't have. And how we do that in a way that is inclusive, both for learners and teachers, brings new challenges for our universities. And I want to start wrapping up my presentation today on how we prepare for the future. AI literacy does not come for free. It requires investments in people, in training material. It requires a transition. And there, both lifelong learning is essential because things are changing fast. The skills that we are teaching today, they will be outdated in 5 years. maybe in two. If we look back, 5 years ago, language AI was not working. So things are changing so fast that we need to teach our students skills and not tools, and encourage adaptability and upskilling, to give them the attitude and the necessary foundations to be able to do that by themselves and through long life learning, but also through modules or micro credentials where they can come and revisit and update their knowledge about how things are changing. So that was all from me. Thank you for having me. This is my experience. I'm very looking forward today for a nice discussion. I have argued that AI is changing the job market and it creates new skill demands. Foundational AI concepts as machine learning, data, and algorithms are essential for responsible use of AI. We need to understand what's going on under the hood, even if we're not able to do it ourselves and build AI solutions. We need to know what it does. AI-infused education involves project-based hands-on learning and interdisciplinary approaches. Curriculum development should scaffold AI learning from early education through higher levels, but also building educator capacity and access to infrastructure is key for this transition. And last but not least, real-world case studies that shows benefits and methods of AI are necessary for curriculum integration. And with that, I would like to thank you very much and open the floor for any questions.
Thank you. Thank you a lot for a very clear presentation, I think, with clear messages also, and sharing your experience. So indeed, it's open for questions. Is there anybody brave enough to have a first question already, or a reflection on what you heard in this talk? Yeah, I see Julian. Please. You can maybe open your camera. Is this? Yeah. Okay. And we can unlock Matthis. Mm-hmm. So yeah, you can unlock your microphone as well now, Julian, I think.
Thank you for allowing me to unlock, Miki. Ioannis, that was a great presentation, really stimulating. You're obviously kind of at the forefront, or at least in the vanguard, thinking about AI in education. I just wondered if you could give a wider reflection on, how other colleagues that perhaps are not as technologically adept as yourself are coping with the introduction of AI and the integration of that into the curricula.
Mm-hmm. Yes, so there is where I think that's why I brought it up, because it's also about us. The younger generation is already born into the internet, and this transition is much easier for them. People with from my age group have been through the internet transition, and now another huge wave is coming, and many of us are not excited with it. We feel vulnerable. We are less flexible in learning new skills. So I agree with you that for me, that was what I was doing even when AI was not working. So it's easy, but I see a lot of my colleagues struggling with that because it requires them to change. But the other thing that also happens on a more positive note is that as AI tools become more and more useful, people are changing and realize that they need to change. And that's also why I spend it more about how AI changes research, because this is the main driver. That if we want to do first-class research today, we need somehow to onboard new methods. So it's no longer, I mean, of course, for many of the research we will do, AI is not relevant. Yeah. So it's not that it will change everything, but there are certain disciplines and subdomains where it has a huge impact. And that's something that is something we cannot ignore, neither as educators nor as researchers. And that is where lifelong learning, engaging, bringing our fellow teachers into that is necessary. Yeah, and I think others today will talk about how it changes the way we teach and the educational methods, and I'm less of an expert on that. I follow them, but I think the most important thing for me is that it changes the way we do research. And that is something that we need to change as well.
Yeah, thank you. Yeah, change and adaptation, it is what we need. I understand. I see another question. Marta, you also have a question?
Good morning, and thank you for a very interesting lecture. I was just wondering, do you consult with students how it should be organized, or can you give us some feedback how they react to the way how you perform classes?
Well, to be honest, my courses and my experiences are with students who are interested in the geeky subjects I'm teaching. So I have a biased audience. But I think many of the life science students we have on campus are really eager in understanding and learning more. Yeah. They're also realizing that this transition is necessary. So they come for this kind of skills. They look for this kind of skills. And this is where this gap between supervisors and educators also happens, that they when they are performing their thesis research, they start using tools that their supervisors are not able to advise them with. So I think students are moving faster than us. I don't know if this is a good answer, but this is my experience.
That would be also my assumption, and that's I'm wondering if you also adapt to what they suggest could be even further or faster, or if this is somehow negotiated in a way.
There is where indeed there is a lot of negotiation going on, because there, on the one hand, you have educators and teachers. We want to keep on being on the old methods, and there is quite some resistance there to change that fast. And there are a lot of ethical, quality related questions. How fast shall we move? Also, from a curriculum design point of view, introducing new topics means that you need to remove other ones. So if we have, let's say, a master in biosystems engineering or agronomy or you name it, in veterinary science, if we introduce two AI-related courses in that curriculum, which ones are we getting out? And that one side of the problem. The other side of the problem is who is able to teach them. And this is where these kind of difficulties are becoming more and more evident, because everybody agrees that we need to do something. But then who is able to do it and how to do it in a program that has a limited space, that requires a lot of negotiations and transitions. And this is also why I'm suggesting, and this is what we are practicing a lot in Wageningen, is to have these microcredits, to include these longitudinal courses where they can be integrated in existing topics, but at the same time, I'm also advocating that we need to look at AI and data science as a topic where we want our students to have deeper knowledge. So not only using it for as part of their practicals, but really understand what happens behind the scenes, because it's no longer what you think. You need to understand what it means in terms of methods, in terms of behavior, probabilities, risks related to that. And that needs to become more clear both to our students and to ourselves.
Yeah. Thank you very much.
Yeah, I think this word of negotiation is indeed very applicable. I think we all understand that. I think there's a nice in the chat also. I mean, we have to adapt and be vulnerable, but also students may need to adapt and indeed embed it. And it's actually more coaching and learning by doing. I think that's a great thing. Maybe a last question we can have. I see Dimitrios has a question.
Yes.
Yeah.
Thank you, Ioannis. Thanks for the very inspiring presentation. I have a question. At the end, you mentioned AI requires investments. I totally agree with you. We are experiencing a period of limited resources, we have to admit. What in your understanding, would be the top priorities in terms of investments there? So if we really want to go into this, and what will be that we would like to start with and then gradually invest in AI to reach a point to solve some of the issues that you also mentioned, Jutta?
I think the number one priority should be human capital. Because if you have the right people in the organization, infrastructure and access to that, I think in all countries, this way or the other can be addressed, or at least for having simple things done. The AI community, the big AI tech companies are very generous right now. They're offering a lot of infrastructure and tools for free, because they want to, dominate the market. That's they do it also for their benefits. But I think the main limitation that I see is having the right people in terms of lecturers, in terms of people who can deliver education, but also design and develop these curricula together with us.
Yeah.
Thank you.
Yeah, thank you. I think that's a nice wording. With all the AI, we still need human capital.
Yeah.
So that will ever be an interaction between technology and really thinking and human capital itself. Okay. Thank you really a lot.
Thank you very much.
Inspiring talk. I think it was a nice question as well.